All right, here we go, everybody. Circuit practice problems with Welty. There you go. All right, so first question is, what are the three components of a circuit and what is the role of each? So battery, that's going to provide the voltage difference for our circuit so that charge can flow or current can flow, right? Also known as the energy, right? This is going to give the charges energy so they can go around and around our circuit. Where do we find our charges? Those are in the wires because wires are great conductors, right? A lot of free electrons in those copper wires. And the light bulb, that provides resistance for our circuit, right? And if we want to light up the bulb, we want that resistance to be pretty high so that the charges will dissipate their energy in the form of light and heat for the bulb. All right, number two, what is current and what is necessary for current to flow? Current is actually defined as, there's our symbol for current, it's charges per time, right? Q is charge and T is time. So coulombs per second. So it's really the rate of flow of charge, right? How many charges are flowing per second through our circuit? Rate of flow of charge, there you go. What is necessary for current to flow? Well, if you remember, we kind of did the analogy to water, and we said, hey, if we have that pipe and we tip it, then the water is going to flow out from high voltage, for example, or high potential to a lower voltage or lower potential energy. So we need a voltage difference for current to flow. All right, moving on here. I'm writing as fast as I can. All right, number 6. Oh, we have our first problem. And it says 6 ohm light bulb is attached to a 24 volt car battery. Sketch a circuit diagram using appropriate symbols and calculate how much current flows through the bulb. All right, so we're just looking to see that you can draw a circuit diagram. So here's our battery from high voltage to low. So we have a long line and a short line. Here's our wires, and here's our light bulb that acts as the resistor. Okay, so there's our 24 volt car battery, our 6 ohm light bulb, and we're going to have current flowing from high to low voltage here. So we can just use Ohm's law. Current is directly proportional to voltage and inversely proportional to resistance to find the current. So 24 volts over 6 ohms, and that's going to be 4 amps. All right, onwards to series and parallel circuits here. So for each series circuit, calculate the total resistance and how much current flows through, right? So, all right, let's look at A. We have 3 resistors or 3 light bulbs here in series. We know it's series because there's only one path for the current, round and round, like our racetrack. And we want to figure out, how much current flows. That's ultimately the deal here, how much current flows. Sorry for that terrible arrow there. We can do a little bit better. We'll just shade it in. How about that? All right. So we want to combine these 3 resistors in series. And if we recall, we just add those together. So R in series is just going to be R1 plus R2 plus R3. So that is going to be 100 ohms plus 300 ohms plus 50 ohms. And so that looks like 450 for our total resistance. Okay, and we want to find the current flowing through that, so that's V over R. So we have our 9 volt battery there. Ooh, good old fashioned transistor radio battery. So 9 volts or 450 ohms, and we're going to get a current of, I need to grab my calculator for this. I was prepared, but it was just a little far away to reach. 9 divided by 450, and I got 0.02 amps. All right, there we go. All right, same thing for B, except we have 4 resistors. 1, 2, 3, 4. And our current's going to flow from high voltage, the longer line, around to the shorter line there, from high to low volts. Again, we ultimately want to find out how much current is flowing, but we have to combine all these resistors first. So in series, well, you have 4 now, and we're just going to add those straight up together. So 65 ohms plus 84 ohms plus 73 ohms plus 10 ohms. And we did this in class today, actually. So that's 232 ohms. All right, and if I use Ohm's law to find the current, how many charges are going to flow per second, that's going to be 25 volts over 232 ohms, which if I remember correctly is 0.11 amps. All right, hopefully that works out. Check it out. So let's move on to parallel circuits. Ooh, I don't know what that noise was, everybody. All right, for each parallel circuit, find the total resistance and how much current flows through, right? Same question, but for parallel. So here's our parallel circuit, and we notice, oh, there's more than one path that current can flow through. Some current is going to flow around our bottom loop or track, and some is going to flow through the top track. So that's how we know that these are in parallel, since current has multiple pathways to go. So we want to calculate the total resistance in order to ultimately find the total current flowing through our circuit. So for parallel, recall it's inverses. So 1 over R parallel is going to be 1 over, in this case, 2 ohms plus 1 over 4 ohms. So 1/4 plus 1/2, let's make common denominator. So I have to multiply this by 2. So that's going to make this 2/4. So that'll make this, ooh, wrong color, Welty. That's going to make that, what, 3/4? Which is not the final answer because that's equal to 1 over R. So make sure we write out our math and keep it simple. We can cross multiply here. So that's really going to be 3R equals, hold on, let's not write it there because I know what I got to do later. So 3R equals 4 if I cross multiply. So R is going to be 4/3 or 1.33 ohms. All right, and so if I want to find the total current then flowing through, see, I wanted some room to write my current. That's V over R again, or 6-volt battery there, over 1.33 ohms. And I don't know that off the top of my head, so I got to calculate it. Here we go, calculator's all ready. 6 divided by 1.33, so 4.51 amps. It's a fair amount of current flowing through our circuit. All right, for B, hey, the first time we've seen 3 resistors in parallel. So now there's 3 paths that our current can flow through. So we're actually going to be kicking out a lot more current because we have to light up 3 bulbs. Here we only had to light up 2. So let's check that out. So ultimately we're going to find the current from high to low voltage here. So for resistance, I have 3 of them now. So it's 1 over R is going to be 1 over the 1 ohm plus 1 over the 2 ohm plus 1 over the other 2 ohm, right? Because it's always 1 over R. All right, let's make this common denominator again. So I have to multiply this by 2. So I get 2 over 2. And if I do that, I'm going to have 4 halves equal to 1 over R. And if I flip that or cross multiply, I'm going to get R is equal to 2 ohms. Correct. Okay, 2, 3, 4. Yeah, 4 halves. No, Welty, no. That's so not right. I got to flip it, right? So it'd be 2/4 or half an ohm. There you go. I caught that mistake because the total resistance of a parallel circuit has to be lower than any of the given resistors. So I knew 2 wasn't right because there's 2's in there, and this has to be less than any of them individually. So 0.5 works out. Little self-check there. So now if I want to find the total current flowing through my circuit, again, Ohm's law, and now I'm going to have 6 volts over half an ohm. I told you this would be more current because I've light up 3 bulbs. 12 amps, which is a very large amount of current through my circuit. All right, cool. There goes parallel. Our last one tonight, and it is Taco Tuesday, by the way. I've already had my tacos. True story. Chicken avocado and some hot sauce. Is our compound circuit. Dun, dun, dun. So compound circuit. There we go. So compound circuit meaning that when we look at this circuit, we can see resistors that are in series with each other and also in parallel in the same circuit, right? Before we said, oh, there's one series circuit or one parallel, but this one, maybe you can see it. There's resistors both in series and in parallel. So we want to combine all 4 of these into one resistor, which would be the equivalent resistance of all these in this arrangement. Okay. All right. So the hint is to combine 2 resistors at a time. And we're looking at the question marks here, really. So if we look here at this first one, we can see that we have a 3, 4, 4, and a 5. And by inspection, if we look and say, hey, 4 and 4, those look like they're in parallel, right? So those are going to be the first ones we'll combine. 3 and 5, they are in parallel, but 3 and whatever this ends up being, otherwise this whole top branch is in parallel with this bottom one. So we can't just say 3 and 5 are in parallel. It's this whole thing is in parallel with 5. So the first thing we can look at is 4 and 4 together in parallel. So let's take a look at that and combine these together into one. So I can do that, and I'll say, all right, 1 over R for parallel is 1 over R1, which is 4 ohms, plus 1 over the other R1, or which is also 4 ohms, I should say. So that's going to be what? 2/4 is 1 over R. And here, if I cross multiply, I'm going to get R equal to 2 ohms this time. All right, so that means these two together are just like a 2 ohm. So we can write in 2 ohms over here. We combine those two into 2 ohms. All right, so 2 4 ohm resistors in parallel are equivalent to a 2 ohm resistor. So now if we look at this, now we can see there's 3 and 2, and those are in series with each other. So let's combine those together, R3 and R2, and that is going to be easy because in series you just add them straight up. So 3 ohms plus 2 ohms, right? Since these are in series, I should write series there. I should have wrote parallel over here so we can keep track. All right, so it's going to be 5 ohms. That was easy. So up here then, this is going to be 5 ohms. Okay, since I have 3 and 2 in series, that gives me 5. So now I can see, the whole top branch of the circuit, which 4, 4, and 3 all combined correctly gives me 5. This top branch of 5 and this bottom branch of 5 are in parallel. So we're going to add those in parallel then. And 1 over our parallel, I'll write it out so we remember they're parallel, is 1 over 5 ohms plus 1 over 5 ohms again. So it's going to be 2/5. That's not the final answer because that's 1 over R. So again, if I flip it, or if you want to cross multiply, R is going to be 5 over 2, which 5 divided by 2 is 2.5 ohms. So that is our final answer, 2.5 ohms. So if I wanted to make the same circuit and not use 4, 4, 3, and 5, I could use one resistor of 2.5 ohms to do the same job as these 4 resistors. Okay, so that's how we combine all the resistors in a compound circuit, 2 at a time, to get to our final total resistance. Thanks, everybody.